So the purpose of using these solubility rules is to determine if the products of a replacement reaction will be soluble or insoluble. And if they're insoluble, then we see these changes that are usually color changes. So when you have a soluble compound, this is an ionic compound that will form an aqueous solution. An insoluble compound is an ionic compound that will form a precipitate in a double replacement reaction. So first, the aqueous solution you determine using solubility rules, and you have an ionic compound, and those are all ions that are listed on that solubility rules. So that means it's dissolved in solution. So what you see is something that looks like water. So there's water, and it's not only water though. This is a homogeneous mixture where there's something dissolved in there, and it's the ions of the ionic compound. The molecular view shows us that you have the ions and they're separated. They're not, the positive and negative charges are not allowed to interact because there's water molecules in the way. So when you have a precipitate, this is insoluble. This is an ionic compound that is not dissolved. So that is going to form a solid that is not like a solid chunk like a cube or anything, but it's just something you can actually see. So this example, you have two clear solutions mixing together, two clear solutions. At the interface you have this white cloud, which is not a cloud. It's anytime you have a color change, that's a chemical reaction, and this is due to the fact that a solid formed from these two clear solutions. This solid product is insoluble and it happens to be white, but at the molecular level what you have are that the ions are bonded together and they are not separated. They're bonded together, and this is falling to the bottom of the beaker. And so you always will have some small, very, very small amount of ions, but mostly if you can see a color change, then that's going to be a precipitate, which is an ionic compound where the ions are bonded together and they're not separated. Replacement reaction is similar to a single replacement reaction in that things are switching places and you have some new products. So one thing is that there's a general format which are going to contain two ionic compounds in the reactants. So these two ionic compounds can be broken out as not just AB, but the cation A and the anion B. And then the other ionic compound is the cation C and the anion D. Okay, so these ions will switch places. So what happens is that A is the cation and it takes a new partner, D, and it forms the ionic compound written just AD. Then C also takes a new partner. So C was a positive ion and it takes a new partner. Instead of D, it takes the new partner B, the anion. And so cross over and down to write the chemical formula for the new. So you have two new ionic compounds on the product side. And these new ionic compounds that are formed are going to be using the solubility rules to figure out those physical states, whether they're dissolved, soluble, and aqueous, or a solid that's a precipitate. And these are the types of what are called precipitate reactions, precipitation reactions, that are the color changes that are interesting to see for double replacement reactions. So when you form those new ionic compounds, you write the ions with the charge values, and then you use the crossover rule to write the chemical formula. So for example, if you have the ion Mg plus 2 with OH minus, you would take this 2 and you cross it over and down, and you would have Mg and then OH2. The chemical formula has no plus or minus signs, and it should have subscripts, not superscripts. Okay, so that's just an example of the crossover rule, but the solubility rules are what are useful in figuring out what is going to be on the product side. If you have something that's a precipitate, that will show something like this. Two reactants shown, and these two reactants are aqueous solutions. So this is reactant 1, that's CuSO4. That's copper sulfate. or copper 2 sulfate actually. That's copper 2 sulfate as the chemical name, and this is NaOH, so this is sodium hydroxide. And both of these are dissolved. You can see that even though it's bluish, there's no solid in there, and even though that's bluish, there's no solid in there. So these are aqueous solutions, and this could be written as AQ with a physical state after each of those. So what that really means, though, is you have the ions, the aqueous ions, which are Cu2+ and SO4 2-. You also have these ions, instead of NaOH, the compound, you have Na+ ion and you have OH- ion. So basically you have 4 ions, and those ions are all going to switch places in a double replacement reaction. So what happens is that these take new partners. So this copper bonds to a new partner, which is OH-. Okay, and so you would write this Cu plus 2 or 2+ with the new partner OH-, and the crossover rule would give you CuOH2. Okay. Meanwhile, the other sodium takes on a new partner, and so this is going to be sodium plus ion with the new partner SO4, that's 2-, 2-. Okay, so crossing this 2 over and down, you're going to end up with Na2 and then SO4. So this is the balanced chemical equation that's shown here, is that you have NaOH and CuSO4 are the reactant side, and then on the product side you have that CuOH2 and Na2SO4. Okay, and so this copper, this CuOH2 is, you'll find on the solubility table, insoluble. So this is a precipitate, which would be the physical state there. This one, Na2SO4, you would find is soluble, and that would be aqueous as a physical state. So how this looks is that you would have a solution that has this interesting bluish, lighter blue color that's fallen down to the bottom, and that would be this insoluble precipitate, the copper hydroxide.